All right, well, it's the top of the hour, so let's get going here. Good morning and welcome. My name is Tom Tanzi. I'm the chairman of the SunSpec Alliance, and I will be your host for today. And the title of today's presentation is SunSpec Modbus for IEEE 1547. The real purpose, though, is to help you to get ready for smart distributed energy. I think that this is an initiative that is happening sooner than what a lot of people think. I think it's been a long road in the lead up to get to this point, but we're now at the point of quickening where the industry needs to take action and in order to take advantage of the opportunities that are arising in the marketplace by virtue of having smart distributed renewable energy. So thank you so much for joining us this morning. And this meeting is, well, first of all, I guess we should cover some housekeeping rules. So this is a go-to-meeting session. It's not a go-to-webinar session. So what that means is that we're running with an open mic. And so I will ask you to mute yourself if you do not intend to speak or be heard. If you do not do so, I'll simply mute you, and then you'll have to unmute yourself if you want to speak. We certainly do encourage you to speak up anytime you have any questions. Secondly, about questions, we'll be actively monitoring the chat box. We'll deal with questions in a timely fashion. So if something needs to be mentioned in the middle of the presentation, we'll stop and break it and answer the question. Otherwise, we'll save them up for the end. We'll have a good chunk of time at the end for covering all the things you may want to discuss. And the question was raised earlier, but I'll repeat it, that this session will be recorded. And as a result, if you registered for this webinar, you will be receiving a thank you. And as part of that will be a link to the recording. So in case you want to cover anything at the very end, you are certainly welcome to do that. All right, let's get some of the other housekeeping business out of the way. And this is a SunSpec Alliance hosted event. Not all of the participants here are members of the SunSpec Alliance. Nonetheless, we conduct our affairs in the same way every time anyway. And that is to say we abide by our antitrust and intellectual property provisions of the SunSpec Alliance member agreement. And you can find the agreement at the link that is shown on the screen. SunSpec strictly prohibits market participants and their employees who participate in them from using their participation in these activities as a forum for engaging in practices or communications that violate antitrust laws. Confidential or proprietary information should not be discussed in open session. So please contact me or the other SunSpec reps if you have any questions about that. And one more time, this meeting is being recorded. So if you do not agree to have your presence noted in the recording, now would be a very good time for you to leave. We certainly hope that you don't. All right, for today's agenda, we want to cover this very important concept that smart distributed energy is here. I think many people are thinking about this activity as something that's happening in the far off future. And it's not. It's happening in real time. And sooner than you know it, the equipment for sale in the marketplace will need to be 1547 2018 compliant in order to be sold in the United States and in Canada. So with that, many people ask, it's like, okay, well, we know it's here, so what do I have to do to make my product eligible for sale? So what are the compliance requirements? And we're certainly going to cover those. Those are pretty straightforward, easy to say, harder to do. And so on the harder to do front, we want to go into a discussion about how SunSpec can help you prepare your product for market. We can assist you in a variety of ways with regard to providing information, technology, support, marketing service, and the like. One of the chief activities that we have to support you in this endeavor is software that we have for testing and validating the products that are compliant to this important standard. And so we'll dedicate about the last third of the discussion today to doing an explanation and a demonstration of the SVP dashboard.
Okay. Well, I brought her thinking maybe you'd want to walk her, but it doesn't matter. I just brought her because I didn't want to leave her.
All right. Okay. Now we're going to mute everybody.
I can.
Okay. Very good. Thank you. And so that, as I said, we're going to cover the last third. We'll do a demonstration and then answer your questions about how SVP Dashboard works. It is a tool that is used to drive testing and compliance for IEEE 1547. Then we'll cover any of your other questions that you may have. All right. All right, I assert that IEEE 1547 2018 is here, and I think that's a hard message for people to understand. But I think this map that's provided by EPRI at the end of last year, it does a really great illustration of that. Things have progressed since this time, but it's interesting. This is I guess a trivia fact that ISO Northeast in June 1st of 2018, that's when they first said that they intended to support and adopt the IEEE 1547 2018 standard. And a number of other jurisdictions certainly have followed suit. All of those that you see in green have specified active dates. Most recently, on the West Coast here in California, the Public Utility Commission and the Smart Inverter Working Group has been debating California Rule 21, which would be the relevant standard that 1547 would be adopted into. And what's been proposed for compliance date is January 1st, 2022. Now, there's a lot of wrangling that's taking place around these dates. And I noted that some of the advice letters that were posted and the protests and so forth associated with them have come online. And what it looks like is that we're going to be really close to that date. It'd probably be a quarter late. This is the consensus opinion seems to be on March of 2022. But in any case, that's about 12 months from now before all the products sold into to that territory at least will need to be IEEE 1547 2018 compliant. Hawaii went before us. They're the pioneers in this. From a state level, they are set in stone. They're good to go for January 1st, 2022. You see other parts of the country are still going through their debate, but suffice it to say that anywhere that distributed energy is sold and installed in any great measure will be a territory that you'll see a very active IEEE 1547 2018 program in place. The reasons for this are clear. The capabilities of IEEE 1547 are substantially different and more enhanced than its predecessor, and it allows for a much higher fraction of distributed and solar renewable energy to be placed on the distribution grid. So it offers properties that are good for supporting the grid and also good for supporting a vibrant industry. Bottom line is that you're looking at a period of time in about 12 months time that if you're a manufacturer that you need to have your product in order and to and through the process of getting it qualified and made available for market. So there is a great sense of urgency in and around this. All right, so what do you have to do if you're a vendor to get into the market? It's easy to say. You get your product tested with your favorite NRTL or authorized testing laboratory to the 1741 procedure. That incorporates the IEEE 1547.1 test procedure internally. So that will cover you on the functional and the safety testing. The second important point is that you need to get your product certified with regard to data communication. And what I mean by that is that data communication combined with the smart functions represent sort of a step change in the capability of DER. So there are complexities and interrelationships there that are not readily apparent when it first meets the eye. And so on the one hand, you can test for compliance. Does your system have an interface? Yes. Well, you could argue that, okay, that you're done then with that. I would say that is probably a mistake to think of it in that way, because of the fact that these networks will in fact be put into place by the various utility grid operators around the country. And secondly, it'll be quite common that multiple of these networks will be co-located, co-installed. And the illustration on the right helps make that point, that the three default standards for the IEEE 1547 each plays a fairly distinct role. On the SunSpec Modbus front, which we'll be talking about most today, this is the system that's used at the machine level, at the interface level, and for field area networking. And we have it on good account that the vast majority of the market will adopt this interface for equipment, for the simple fact that it's easy to do and the lowest lift to get the job accomplished. But you can't take your eye off the other two protocols. IEEE 2030.5, this will be a very common method for linking utility grid operations back to the DER system. Now remember that DER system is going to have SunSpec Modbus running quite often at the local network. And so the fact is that these systems need to marry with one another. Likewise for IEEE 1815, which is commonly seen in utility substations. The back end of an IEEE 1815 system has a lot of Modbus components, and if those things need to work well together in order for the overall system to function in the right way. Last point I'll make here is that we have depicted at the bottom this SunSpec authorized testing laboratories, and so we made it a point to bring in a combination of NRTLs that are able to handle both the functional testing capabilities and the communication capabilities, as well as some communication specialists that focus really strictly on the parts of the system that do not do power conversion, but that focus in on the data communication. We were made sure to do this knowing that during this peak period, there's certainly going to be a high need, high demand for this type of testing. And we wanted to make sure that we're prepared with well-qualified and trained testing houses that will help us take on this very important job. All right, so to prepare your product for market, some may look at this slide and where I say, hey, well, the first thing you need to do is get a copy of IEEE 1547 2018. From a certain point of view, if that's where you are as a hardware manufacturer, well, you have a difficult job ahead of you, because there's a lot of work to be done there. So let's presume, and which I think is proper, that most companies are probably pretty far along with their hardware designs at this point, and they've been looking at these smart functions for some time. Some others that are doing system integration, though, this may be a relatively newer topic, so this advice for you of getting your hands on the copy of the standard might be a good one. For many products in the market, though, it really is sort of getting down to the fine points of preparing your product for market in a certain jurisdiction, and whether that's the Northeast or the Midwest or here in California. And there, the fine-tuning, it has to do with communications requirements and meeting the compliance criteria for the profiles that each of these jurisdictions either have or are considering bringing online to lay down in very specific detail about what's required to operate in their jurisdiction. In any case, you'll be focusing in on the communications aspect of your system. And to assist you in that journey, first point you at the trio of standards in the lower left, SunSpec DER Information Model Specification. the Device Information Model Specification, and the SunSpec Information Model Reference. These documents have all been updated to coincide with the publication of IEEE 1547-2018 and include what you'll hear about more in this session, which is the 700 series models for DER. So this is a pretty big upgrade for us, and after 10 plus years at this, we're very proud of the achievement that we've made here. So that's a great place to get grounded. Now, once you have that in place, if you want to get yourself acquainted with how these systems work, and you're a SunSpec member, we recommend that you take advantage of the fact that SVP Dashboard is available to you for the cost of your annual membership. Including an SVP Dashboard is a DER simulator that utilizes all of these different SunSpec models. And so using this tool, you can query the system, poke it and prod it, assign new values, and see its effects. And so as a result of that, you can also run a test against it and see how the validation process works. So that's, again, a good training exercise for you to help understand the interrelationships of the different models and how everything really works together. So this, of course, is not intended to be a sequential recipe, but continuing this sequential manner, once you've oriented yourself, the next thing is to start writing some code for your system. And on the lower right-hand screen, this is a screenshot out of the Pi SunSpec 2 documentation that just describes how that system works. Well, this is reference software that's available to anyone in the public by going to GitHub. You have to sign the open source license, but nonetheless, it's available to you. So then, of course, with that comes a lot of software development, and ultimately, you're ready to ship your product to market. But before you do so, you need to do testing and validation. And so here, SunSpec is introducing here today the Plus Pack for SVP Dashboard. Now, this is a product, and that's supported by our organization. It's available for an additional fee. It's not included in membership, but we are charging, I think, what you'll hopefully agree is a modest fee to provide some very significant capabilities to test and validate these IEEE 1547-2018 products. So that's, in a nutshell, what's required. Now let's go into more of the details. So for background, if you're not familiar with SunSpec Modbus, please do visit our main webpage, which you see here at sunspec.org. And this is a 10-year effort. Some of the things I would like to point out is that the original charter of the SunSpec Alliance, and we are a trade alliance, was to develop common information models and a common interface for balance of system components that make up a PV system, or distributed energy system. But in the early days, we thought in terms of solar systems. The very first work that we did had to do with the inverters. It was followed by the meters. We broadened out pretty rapidly to cover the whole array of different components to go into the system. And we have a robust support for about 10 different major components of the system. As IEEE 1547 came into being, though, it was really returned to the past, where the focus then became very clearly on the DER in the inverter and in the energy storage. So as also the other aspect influencing our work was the fact that these other communication protocols like IEEE 2030.5 and IEEE 1815 at one point were being considered for inclusion in the 1547 standard, and ultimately were. And so one of our main missions here with this technology is to make sure that all the different communication interfaces are semantically identical and fully interoperable with one another. And so that's one of the core values that you get out of SunSpec and SunSpec Modbus. In any case, this is the place where you would start your journey to learn about this. With the advent of IEEE 1547, we undertook a pretty significant upgrade of the SunSpec Modbus interface and published it ultimately in 2021. The system has been stabilized for well over a year from now. We went through, I would say, a rather protracted evaluation and review phase simply to get things right. And there was debate taking place up until relatively recently, and we made sure to capture all of that dialogue and answer all the important questions from the early adopters that we could. And so with SunSpec Modbus 2021, you're going to see a new set of models in the series of models, this so-called 700 series. These match the IEEE 1547 functions on a point-by-point basis. And it very specifically addresses the compliance requirements that are laid out in the test procedure as well. Equally importantly, we've had a lot of adoption over the years. Some people don't know this, but we've been a national standard in various places, including the country of Denmark, for going on 8 or 9 years. And so we've had pretty broad adoption, that country, across the United States and Europe as well. And so we've learned a lot. One big lesson that we learned as we got into energy management systems happened to be about scalability. And so we reworked our models in those ways. And so this resulted in this new DER information model specification that is called 700 series. We also enhanced our technology pretty significantly by extending the modeling capability, and again on 2 dimensions, scalability, as I mentioned, and then interoperability. So in the scalability, where this came in most prominently had to do with the elements in the system that were repeating in nature. When you have a large-scale energy storage system, that's one of those. And then on the interoperability front, as I mentioned, these other 2 IEEE 1547 standard communication interfaces, the 2030.5 interface and the 1815 interface, also known as DNP3. These are important interfaces in different parts of the system, and so that identically semantic characteristics interoperability was a very high priority for us and a main goal. Another component of upgrading the technology was our move to JSON for model definitions. XML, at the time we started 10 plus years ago, it was the base standard. Well, time moved on and developers moved on. JSON became a very popular and lighter weight standard. And this adoption of this particular technology has allowed us to better interfacing with tools and better understandability by the vast majority of engineers out there. So that was an important upgrade. And finally, all the SunSpec model definitions behind this technology are available on GitHub. SunSpec, as a trade alliance, we're for the benefit of the industry. Our main goal is to define information standards so that we can grow the market, and supporting open source is an important aspect of that philosophy. I talked about the 700 series models and how they relate to IEEE 1547 2018, and here they are. And you will see that their names, if you're familiar with the IEEE 1547 standard, you see that their names come directly out of that standard. And each of these functions is matched to the precise functional requirements of that 1547 component, whether it's for DER capacity, AC controls, volt var, and the like. Another important aspect of this this capability, this technology, if you're a longtime SunSpec implementer, is that this functionality supersedes the 100 series inverter models. And so according to how SunSpec works, we always support interfaces that we publish, and once of course a product is certified, that means it's forever, but the certification is tied to a set of models. And so these models are the recommended ones if you're developing inverter-based products. You can certainly use the others, but if you want to sell in the territories that require IEEE 1547, this is definitely the preferred method and the path of least resistance, and of course, also the path of greatest capability is to utilize all of these models. Another important distinction is in the past, implementers were sort of free and choose to pick which models that they would like to support. And with the IEEE 1547 compliance requirements, your degrees of freedom are significantly less now. And in fact, all the models that you see listed here are part of being a IEEE 1547 with SunSpec Modbus compliant device. So all the models are in fact required. Now, if you're a system designer, you're building an energy storage system, all the flexibility that you had before of mixing and matching other SunSpec models absolutely still exists. So you can pick from our complete array of information models that we support, including for vendor-defined models. And so this is a way of encapsulating proprietary or vendor-specific information, but making it available in a standardized, easily accessible way. All those capabilities are able to be mixed and matched in a device that supports these 700 series models. So you have all the same flexibility as before, plus that level of interoperability and compliance that you're looking for. Some other very important aspects in terms of how SunSpec has evolved and how the market's evolved is that there's a real drive in the marketplace for certification profiles. And for those of you that have kept tabs on this situation, you'll see that there's of course all that nameplate data, but then there's also region or state or location specific settings that may come into play. And in some cases, there may be other functionality that's required. An easy one to point out there is for energy management systems. You may have a requirement for battery models and the like that would need to be in these profiles. But the point I'm making here is that we've sort of embraced this concept of certification profiles. And as you'll see in the way that the product works in terms of the SVP Dashboard products, where it scours the device to see what's capable, it generates a PIX, then it generates a test procedure for that particular device. And then, of course, once you get into the testing mode, you run that test procedure and evaluate the results. And well, as it turns out, if in your implementation, you've built a device that covers 1547.28, Maryland requirements, Poland requirements, EV requirements, if your interface has all of that, when you're through with your certification, you will get special marks showing that you meet those various requirements. So that's important for people that are seeking status and like to achieve. It's also important, though, for qualifying your product for market. Ultimately, much like the state of California has done with its approved equipment list, you're going to see these approved equipment lists pop out all over the country and the world, where the jurisdictions will be looking for very specific capabilities to qualify your product in their jurisdiction. And these certification profiles do exactly that. And on the tools front, we have updated as well the PySunspec 2, the Python library. This is in very broad use by implementers. The 2 indicates that it's for second generation, so it includes support for all the JSON objects. You can get that at GitHub. Just search for the SunSpec project there. SunSpec Dashboard, which you'll hear about more in just a moment, that's available to members at no cost. And as I mentioned, the Plus Pack, which is available to members for an extra fee that also includes automated testing and scripting for SunSpec certification and IEEE 1547.1 functional testing support. And we'll get into detail on that. So I won't waste time here other than just to note that this exists as a tool for you. So once you do get your product certified, you want to let people know about it. We offer the SunSpec Product Certification Registry for that purpose. To date, we have certified over 110 different product lines, 62 to the Modbus standard. And with this registry, you'll see both the protocol information conformance statement. You'll see the certificate, so you know who tested it, when they tested it, what the hash value of the software that was tested, and in what condition and what time it was done. So this is exactly the information that the authority having jurisdiction wants in order to properly qualify your product for jurisdiction. Now, this certification registry is built on another SunSpec technology, Orange Button, and that offers another open interface that makes it straightforward for one website to communicate with the master service via an API to download and update this type of information. So knowing that this type of information is going to be needed by buyers and by authorities having jurisdiction, we put this system in place for that purpose. That's yet another benefit of the SunSpec way of certifying products. All right, and I mentioned the relationship of SunSpec Modbus to these other types of systems and the importance of certification. And I think that this particular picture drives that point home. So for most manufacturers, job one is qualifying yourself to be sold in the given region. And so getting your UL1741 certification, proving that you can communicate in a standard way, that allows you to do that. Then the next step is making it work in the field. And so making it work in the field can be quite a bit trickier. And so here's the classic example and environment that is present in California, where California requires IEEE 2030.5 for utility, a network operator to system communication. Now, of course, that's all going to be done over the 23.5 network. Once you get to the local system, what you're going to encounter quite often will be SunSpec and SunSpec Modbus. And so ensuring that we have this semantic identical behavior and compatibility is the key trick. So the best way to get this done is to certify these products. When you do so, you plug them and play them, and they all work together well. And this, of course, gets better with time. It gets wrapped with security services. And actually, this is another point that I want to make and will make at the end, is that getting compliant is important. Thinking about the security implications is also another point of improvement that I think many in the industry will need to embark on. All right. With that, I want to save the remaining time. We have about 27 minutes. We're going to go through an SVP dashboard demonstration, and at that point, then we'll have a question and answer. We have our principal engineer Bob Fox online, and he and I will be able to take your questions. And Bob, if you could do me a favor right now and start to look at the chat questions and key up any of them that that may seem pertinent while I run the demo that's going to feature your voice for SVP Dashboard. All right, so without further ado, let's talk about SVP Dashboard. It's a software tool. It runs on Windows. It's used for developing, testing, and maintaining SunSpec compliant interfaces. It's used to generate and manage artifacts that are needed in the certification process. One of these things is a PICS, Protocol Information Conformance Statement, and this is the manufacturer's declaration of the capabilities of the product. It supports, the dashboard does, each step of the Modbus certification process from the standpoint of helping developers at the very early steps of conceptualization, working through the testing products, and then, of course, getting listed. It's a Windows application that you're going to see. Windows 10 is recommended. Other versions are supported. It's licensed at no additional cost to SunSpec members. And this is SunSpec SVP Dashboard, the basic edition. and you'll see the capabilities of this basic edition. Very capable. Includes a protocol information conformance statement generator, includes a DER simulator, and it includes the ability to digest and parse out a Modbus traffic stream and the like. Some other important operational considerations are that it does install and run as a normal Windows application, but it's not a normal Windows application from the standpoint that it runs as a web service and it interfaces through a browser. And the browsers that we support today are the important, we think, popular ones: Chrome, Firefox, and Edge. Unfortunately, it does not work with older versions of Explorer, so Edge works just fine. So we have good coverage across the different interfaces there. It provides a Restful Web Service API. So this is how the web app interacts with the API, but this serves another important purpose for those manufacturers and software developers that have their own test harnesses. That would be, I guess, all of you. And for those of you that would like to have programmatic access to this sort of capability, that is certainly not only possible, but enabled through this system. And so it's made to be easy to adopt, either for a shop of one person, where it's an all-in-one tool, or in a very large organization, which is where it's just part of the toolkit. All right, so that's the setup for SVP Dashboard. Let's get into it. All right, well, as we join the demo, I want to remind everybody that we're running in Windows 10. This is a demonstration is being done in Windows 10. And so without further ado, let's get started.
Once the dashboard is started, you'll see this opening screen. This screen represents the web service that's running. If you close this screen, the dashboard will close. To access the user interface, you can click on the link in the window, and a tab in your browser should open automatically, and the dashboard screen will be minimized on the toolbar below. This organization allows the dashboard to be integrated into other tools environments and be accessed through its web service API to perform operations. This is especially useful for interfacing with the testing functionality contained in the dashboard from other testing environments. Once open in a browser tab, we see the dashboard display with the menu items above. In the top level menu items are Device, Tests, Tools, and Help. One of the primary sets of functionality in the dashboard is the ability to interface with a SunSpec compliant device through the SunSpec interface. The items in the device menu support operations associated with the device. The device menu contains Open, Close, Create PIX template, Create certification test, and Export. To perform any of these functions associated with the device must first be opened. We'll open a device in a moment. The Create PIX template and Create certification test menu items are used in the device testing process. We'll look at those in a minute. The last item in the menu is Export. Export provides a way to save the data contents of the device to a file for later use. The Test menu provides access to test suites that have been created in the dashboard. We will see how test creation works when we look at testing. Tools menu contains additional functions that are useful in the SunSpec environment. The first two items, Models Directories and Update Model Definitions, are used when working with model definitions. The last item is DER Simulator, which provides the ability to create SunSpec compliant DER simulators for development and testing purposes. And the last menu item is Help. In the Help menu are User Guide and About. The SVP Dashboard User Guide opens in another tab and contains information about all the available functions and provides tutorials explaining function usage. The User Guide can be referred to at any time for help and left open in the tab. The second item in the Help menu is About, which gives information about the dashboard, including version, dashboard ID, which is important when getting the dashboard license, and the information about licensing. Now we'll use the dashboard to create a simulated DER and open it as a device. I'm going to start a simulator, which defaults to a standard IEEE 1547-2018 compliant implementation using the SunSpec DER information models. The simulator defaults to Modbus TCP on port 8502. The dashboard supports Modbus TCP, Modbus RTU, and an additional device called File. The Modbus TCP and RTU options provide the standard networking options for each. The third option allows previously exported devices to be loaded and used as device data. This allows simulated interaction with a device image for testing and debugging purposes. Using the device open option, we can interface with the simulator. We see the display window populated with two kinds of model information. In the top bar, we see the information model IDs of the models that were discovered in the device. And in the main portion of the window, we see the detailed information for Model 1, the selected model in the list. Each row in the table represents a data point in the model. There are three main columns of detailed model information for each point. The left column is the data point label and point name as defined in the information model definition. The middle column is the current value for the data point, and the right column is the Modbus address of the data point and the data contents as it would be seen in a Modbus message. Looking at a more complicated model, such as Model 705, which is DER volt bar control, we can see all the points associated with the volt bar model. Points that are writable have input fields that allow them to be updated here and written to the device on command. We can see this volt bar model implements three control curves. Using this interface, we can examine and update all the points in a model. The dashboard can support all models that have a model definition, including vendor-specific models created by manufacturers. Now that we have an open device, let's look at the testing-related options. The two options associated with testing are Create PIX Template and Create Certification Test. When testing and certifying a SunSpec Modbus interface, a Product Implementation Conformance Statement, or PIX, must be submitted. The PIX is a detailed implementation statement in the form of an Excel spreadsheet that indicates which models and points are supported in the implementation. The dashboard uses the contents of the device to create an initial PIX template. The PIX template is then updated by the submitter to add any information that could not be determined by the dashboard. Once the PIX template is complete, the dashboard can dynamically create a certification test suite based on the PIX template. The certification test suite contains tests for each of the models contained in the device. The testing ranges in the tests are based on the supported ranges specified in the PIX for the points in the applicable models. When a test is created, it is added to the test menu. This menu contains a test that was created based on the PIX associated with the current simulation configuration. We can access the test environment by selecting the test in the Test menu. The test environment opens in a new tab. On the left, we can see the complete test suite associated with the device based on its PIX. Within the top-level suite, we see test suites based on each of the models contained in the device. Each model test suite contains a set of tests that are applicable to the model. Looking at the volt bar test suite, we see the individual tests that are run. We can select any combination of suites or tests to run. I'll select the volt bar test suite and run it. As the test runs, a result indication is given for completed tests, and a progress indicator shows which test is currently running. You're also able to stop the test run at any time. I'm going to stop the test now. The test results and the detailed logs for each test in the test suite are saved in a results file. The results files can be inspected later using the same interface with the same navigation capabilities that are available during testing. Here we see a full test run completed earlier and are able to browse the detailed test results. As mentioned earlier, The test can be selected and run through the graphical user interface or through the Web Service API, allowing the test selection, initiation, and results retrieval to be integrated into another test system. This has been a quick overview of the full functionality of the SunSpec SVP dashboard. Some of the functionality shown may require additional licensing beyond the SunSpec membership license. To get more information about any of the features, check for additional demonstrations and documentation on the SunSpec website.
All right. Thank you, Bob. Appreciate that.
Once the dashboard is started.
All right. Thank you. Again, at this point, we'll open up the microphone for questions and answers. And if you are a SunSpec member, please do just send an email to membership and ask for a dashboard license if you don't already have one. Anyone can get the basic dashboard license. For limited time, we're also going to be running a beta just for a few more days here, actually till the April 15th, for the automated testing capabilities. After that point in time, then that becomes a licensable fee for. So that now is a good time if you're interested to take a look. You can. With that, I would again like to open it up for questions here. And so, Bob, were you able to spot anything in the chat box that warranted?
Yeah, sure. Let's go through them. So Greg Kern asked, isn't the communication certification only required by California? So I think that addresses the broader question about your broader point about the benefits of certification, but do you want to address that one specifically?
Well, sure. Yeah. In terms of the certification, yeah, this is not necessarily written into any law. This is I think it's a practical advice for vendors. It's very easy, as we've discovered over the years, to produce an interface that might pass a trivial test, but doesn't work in the full range of its protocol options. And so really this is a really more of a certification that's about adding quality and interoperability than anything else. Now, as in terms of what other jurisdictions require it, I mentioned the outside of the U.S., of course, we have some jurisdictions requiring it, and I think you can expect that to be replicated across the U.S. But at the moment, for most part, it's effectively voluntary, but an important aspect.
Okay, and there's a question about frequency watt. Where is frequency watt? This is a commonly asked question about 1547 2018. It's frequency droop, and Gordon answered that one. But frequency droop is the frequency watt function in 1547 2018. There's a question, is the protocol applicable for the state of California? So I think the answer to that is probably the way Tom outlined the likely scenarios of SunSpec Modbus at the DER interface and 23.5 in the white area. That's going to be a common pattern. So it is, I believe, applicable for the state of California.
Yeah, what I would add to that, and those of you that have been participating in the Smart Inverter Working Group can certainly attest to this, is that California was ahead of the rest of the country, driving a lot of the requirements. And what they have agreed to do at the Public Utility Commission is that as and when the 1547 standard was available, that they would then update their interconnection agreements to reflect that. And we're midstream on that. This process being repeated across the states, where you have existing interconnect regulations that are now incorporating 1547 2018.
Okay, another question from Jason was, Tom, you talked about the gateway model. Can you talk about the direct to aggregator model?
Okay. Direct to aggregator model. That is a concept. Well, okay, that's a IEEE 2030.5 concept, not a SunSpec Modbus concept per se. However, could be, I suppose. And I will answer it thusly. Whether it's a client, server, or an aggregator in IEEE 2030.5, SunSpec Modbus has semantically identical representation of the information that is transferred to support these smart DERs. So again, it's an important consideration just for the fidelity of your signal. The more common, I think, application of the gateways would be a local client running on the close to the DER system, interfacing with Modbus. But you are correct, Jason, that the other scenario is equally applicable.
Okay, the next question is SunSpec tightly coupled with Modbus. Would I be able to certify a SunSpec over maybe CAN? So yeah, this is a great question, and actually represents specific work we've done in our revision. So the SunSpec device information model specification, which talks about SunSpec modeling, as Tom said, was rewritten, and we went to a lot of trouble to emphasize the fact that the information models can be used in context other than Modbus. So obviously there's Modbus has registers that have addresses, and there's a sequence associated with the information in Modbus, and that is supported in the information models. But in that specification, we separated the encoding from the model definition in a very specific way. And so our intention is to start looking at other encodings to be able to use the SunSpec information models with. JSON encoding over a simple RESTful web service is one that we've been talking about for a while, and I think there's a lot of interest in being able to do SunSpec over a simple web service interface. But it would be possible to adapt SunSpec to other encodings as well, and possibly even CAN. We haven't looked at CAN in detail, but I just want to make the point that we're about to embark on looking at other encodings besides Modbus for the SunSpec information model content.
And Bob, Greg Current makes the point that whereas that what you said is fine and true, that CAN interface would not qualify as a standard interface under IEEE 1547, as it explicitly calls out Modbus. But in fact, the compatibility is there.
That's true. But SunSpec, another common use for SunSpec is for system integration purposes. So, you know, the outward-facing grid interconnection use case is the one that is on everyone's mind. But when people are doing systems integrations with different pieces of equipment, Modbus and SunSpec Modbus is a great solution. So there are places where SunSpec Modbus is used that isn't necessarily subject to 1547 or grid compliance considerations. So there's definitely a broader context for SunSpec Modbus in use today, and other encodings would certainly be welcome there.
Hey, I see Jay Correa asked, can this dashboard be used only by organizations who are a member of the SunSpec Alliance? And Jay, the answer to that is yes. And this is more of a feature of a mutual benefit society than it is anything else. So SunSpec is a nonprofit 501c6 organization, which means that we're set up for the mutual benefit of our members. And so we offer very modest annual fees for our service, and included in that are valuable benefits like software. So if you do a comparison shopping, I think you'll find out that that the cost of membership, given the benefits you get, is worth it. But if you have questions about that, please do contact us, membership at SunSpec or Tom at SunSpec, either one, and we'll be happy to take you through that.
Yeah, a question from Robbie Simpson. A great tool. Any consideration of providing something similar for other standards Modbus SunSpec certifies, such as IEEE 23.5? The answer is yes, and that is a great introduction to another tool we're working on, the Nonstop Interop platform, and that addresses 2030.5 specifically, but we're also considering 23.5 support in the dashboard as well. So if you're interested in 23.5 testing, I would encourage you to look at the Nonstop Interop solution that we're developing, and that would be available on the SunSpec website. Anything else you'd like to say about that, Tom?
Nope.
Okay.
No, I think that's enough. Let's stay on the Modbus topic.
Okay. Is the Restful Web Service API available without cost? Yes, it is. Is there documentation available? We're working on that. So the Restful API documentation is in progress, and we will be releasing that shortly.
And the Restful Web Service interface, that's for use in for accessing local instance from whatever tools that you may have. So yeah, so that's all for local data interchange.
And the primary emphasis initially is for interaction with the test system, for invoking the test, configuring, invoking, and getting the test results. So that's the primary use case. And to different aspects of the dashboard, we will be expanding. The DER simulator is one, the web interface is another. So this is the initial instantiation of it, and those functions will be being enhanced.
Okay, I see we have a question about what does it cost to join SunSpec. So our annual dues are $3,000 per year. And it is in fact an annual membership, and there's plenty other capabilities that we offer besides this. And we're nearing the top of the hour, so I also wanted to make sure that folks know about this new course that we're introducing at UC San Diego for implementing SunSpec Modbus. This is a 3-unit academic course. It's a programming boot camp for utilizing SunSpec Modbus. It incorporates the use of the tool that you saw here today. Students get a special version of that for use in the course. But the point is that we're going to have a big rush at the door here, I think, of the testing houses, and so now is a really great time to get prepared for that. For SunSpec members, anytime we have these educational opportunities that there's a fee for, which this one does, SunSpec members get significant discounts. I think 20% discount for this one. So again, let us know if you're interested in that. And finally, I'd like to close this session with effectively a sort of a call to arms. Yes, we need to get our products ready, and part of that is to get them up to speed with regard to cybersecurity requirements. I think as we get beyond this initial rollout, conversation is going to switch from interoperability to security very, very quickly. And so this coming Thursday, we have Jeremiah Miller from the DOE Solar Office of Cybersecurity coming to give us his perspective on this 50-state solution. So this will be held 2 days hence at the same time, I believe. And if you want information, please do contact us at sunspec.org. And we offer also a lot of our different webinars and so forth on our YouTube channel that you see it down there. We also have special member section here where we have member only content that you get video, audio nature. So there's a lot of resources that are available to you to really understand and take advantage of your capabilities in this area. And with that, I want to thank each and every one of you for joining us here today. And we appreciate your time and attention. We look forward to engaging with you. And so just email us there. We can help you with licensing, with the SVP dashboard, with membership, with education, anything else that you may wish to discuss with us. So with that, we're at the top of the hour. Thank you so much for your time and attention today, and have a great day.